we already just learned 1 to 8 theorems. Okay, today class we are going to start with theorem number 9. The angle subtended by an arc at the center of the circle is double the angle subtended by an arc at any point on the circle outside the arc. That means angle subtended by an arc at the center is double than the remaining part of the circle. So this is angle subtended by arc at the center. This is 2x, which means this will be x. Okay, this is x mean this will be 2x. Okay, double. This is double mean this will be off. For example, okay, this is DCB. If this is 100, then x it will be 50. Okay, x it will be 50. If x is 50, angle DCB it will be 100. Angle subtended by an arc at the center is double. This will be double than the remaining part of the circle. Here, the same as POQ, this angle, POQ is twice, okay, 2 times than the PAQ. So POQ means this is, suppose if this is 30 degree, POQ it will be 2 times 30. Okay, 2 times 30 means this will be 60 degree. Subtended means, okay, this is your eyes. If you are just seeing any 2 points, the angle will form. This is nothing but angle subtended. Okay, next one is corollary. Corollary is nothing but a corollary is an immediate result of the theorem. Okay, is an immediate result of the theorem. Here, first one, the angle subtended by a diameter at any point on the circle is 90 degree. Angle subtended by a diameter. Okay, so diameter is of the circle is 90 degree. For example, if you are just taking AB is the diameter, okay, angle subtended by an arc. Okay, by the diameter is 90 degree. Now this will be 90 degree. This angle is 90 degree. Here, AB is the diameter. Now this is 90 degree. Or here also this is 90 degree. And another way we can say the same statement is angle in a semicircle is right angle. Angles in a semicircle is right angle. If its diameter means it will be dividing into 2 equal half. That is a semicircle. On another way we can say angle in a semicircle is a right angle, that is 90 degree. In 2 different way you can just say. Okay. Now the next one, angles in the same segment of a circles are equal. Angles in the same segment. For example, here DB is the same segment. So DB is the same segments. Angles in the same segments are equal. This is theta means this is theta. This is 50 means 50. 60 means 60. 70 means 70. Angles in the same segments of the circles are equal. Next, theorem number 10. If a line segment AB joining 2 points A, B subtend equal angles at 2 other points C and D that lie on the same side of AB, then the 4 points lie on the circle. Okay, ABCD is lying on the circle. This is called as concyclic circle. Okay, we'll be saying that ABCD is a concyclic circle. Why? Because all the 4 points are lying on the circle. If AB is a chord subtended equal angle C and D, then the 4 points will be lying on the circle. Okay, next one is cyclic quadrilateral. A quadrilateral ABCD is called a cyclic if all the 4 vertices of its lie on the same circle. Okay, ABCD is a quadrilateral. If all the points of the quadrilateral lying in the circle, this is called a cyclic quadrilateral. If a quadrilateral lying on the circle, that is called a cyclic quadrilateral. Cyclic quadrilateral means a quadrilateral ABCD is called a cyclic if all the 4 points are lying on the circle. This is called a cyclic quadrilateral. If it's cyclic quadrilateral, then we have one more property. That is, okay, theorem number 11. The sum of 2 opposite angles of a cyclic quadrilateral is 180 degree. Okay, if it's a cyclic quadrilateral, ABCD is a cyclic quadrilateral, sum of 2 opposite angle is equal to 180 degree or supplementary. So A plus C is equal to 180 degree and B plus D is equal to 180 degree. Okay, sum of 2 opposite angles of a cyclic quadrilateral is 180 degree. Then next is a converse. If sum of two opposite angles in a quadrilateral add up to 180 degree, then the vertices of the quadrilateral lie on the circle. Okay, it will be lying on the circle. That is called as concyclic. If 4 points are lying on the circle, that is called as concyclic. Okay. If it's a cyclic quadrilateral, sum of two opposite angles is equal to 180 degree. If sum of two opposite angles is equal to 180 degree, then all the 4 points will be lying on the circle. So exercise set 5.6, question number 1. In a circle with center O, the central angle AOB is 60 degree. If the radius of the circle is 12 centimeter, what is the length of the chord AB? Okay, first you have to draw the circle with the center O. Then the center angle AOB is given as 60 degree. Okay. Next, radius also is given 12 centimeter. They are asking the length of the chord AB. Okay, here is the diagram. A circle with center O. AB is the chord and AOB is 60 degree. And they have given radius. Okay, radius is given as 12 centimeter. Now this is radius 12 and this is also 12 centimeter. They are asking what is the length of the chord. Okay, length of the chord AB. So in a triangle AOB, two sides are equal. Okay, two sides are equal. I can just say AOB is an isosceles triangle. If it's an isosceles triangle, angles which is opposite to the equal sides are equal. Or we can say base angles are equal. If this is an isosceles triangle, so base angles always it will be equal. If I take this is X and this is also X. Okay, so based on this, we can just find out, okay, third side. Okay, now I'm just taking as AOB is an isosceles triangle first. Okay, why? Because two sides are equal is given. Therefore, I can just write first triangle AOB. Okay, triangle AOB is an isosceles triangle. In isosceles triangle, the angle opposite to the equal sides are equal. Or we can say base angles are equal. I'm just taking the base angle as X and X. Again, I can just use angle sum property of triangle. If I use angle sum property of triangle, right? Triangle AOB. In triangle AOB, okay, in triangle AOB, using angle sum property of triangle, I can just write it as X plus 60 degree is equal to 180 degree. Okay, sum of three interior angles of a triangle is 180 degree. This is nothing but angle sum property. Okay, angle sum property. So x plus x is I am getting as 2x. So 2x plus 60 is equal to 180 degree. Okay, now 2x plus 60 is equal to 180. So we can just take it as the 2x is equal to 180 minus 60. Okay, so 180 minus 60 you'll be having as here. So now 2x is equal to 120. Now x is equal to 120 by 2. Okay, 120 divided by 2. So 120 divided by 2 is 60 degree. Now x is equal to 60 degree I am getting as. That means this is 60, this is also 60, this is also 60. So all the three angles are equal to 60 degree. Therefore, I can say AOB is an equilateral triangle. Okay, all the angles are equal to 60 degree. Therefore, I can say AOB is an equilateral triangle. Okay, so x is equal to 60 degree. Therefore, I can say AOB. Okay, therefore, triangle. Okay, I can just write therefore triangle AOB is an equilateral triangle. Is an equilateral triangle. Equilateral triangle. If it's an equilateral triangle, we know that all the sides are equal and all the angles are equal. Okay, all the angles are equal. Therefore, this is an equilateral triangle. If it's an equilateral triangle, all the sides are equal. Okay, therefore, I can say AB is equal to 12 centimeter. AB is equal to 12 centimeter. They ask us to find out the length of the chord AB. So AB is equal to 12 centimeter. So we got it. Question number 2. Let A and B be 2 points on the circle with center O. First one, are there the point x comma y on the circle on the same side of AB such that angle AXB is different from AYB? Okay, we have to take 2 points A and B on the circle with the center O such that they are asking if x and y are on the same side of AB, AXB is different from AYB, they are asked. Okay, now actually the diagram will be like this. Okay, this is the diagram. Okay, let A and B be 2 points on the circle with the center O. X and Y on the circle of the same side of AB. Same side of AB. They are asking AXB is different from AYB. We already learned one of the theorem. Angles in the same segments are equal. Angle X is equal to angle Y. Okay, both it will be equal. They are asking, is it different from AXB is different from AYB? So the answer is no. They are not different. So both it will be equal. So we know that angles in the same segments are equal since both AXB and AYB is in the same arc or same segment AB. Therefore, AXB is equal to AYB. Okay, thus the answer is no. If X and Y are in the same side of AB, then AXB is equal to AYB. Okay, angles in the same segment should be equal. Now the second part is it true that if AXB is equal to angle AYB, then X and Y lying on the same side of the circle? Okay, if angle AXB and angle AYB is equal, mean is it necessary that X and Y should be lying on the same circle? Okay, now actually the answer is no. We can have a diagram like this also. AB is a point on the circle. Here AXB and AYB. So both are in opposite direction. They are not in the same direction, same side. They are in the opposite side. Even though the angles are equal, 90 degree, 90 degree. Why? Because we are just considering AB as the diameter. Okay. So angles in the semicircles are equal. This is 90 means this also should be 90. Okay. So therefore this is also possible. Okay. Therefore this is not always true because X and Y can be opposite arc and be equal also. Okay. But if they are on the same side, same segment, then that should be always equal. Okay, if both are in the same side of AB, that should be always equal. But this is also possible. Okay, it can be in opposite side also, it can be equal. Okay, so the answer is it is not always true. Okay, right. Third subdivision, if angle AXB is equal to angle AYB and X and Y do not lie on the circle, does the circle through A, B and X also passes through Y? Okay, if angle AXB is equal to AYB and X and Y do not lying on the circle, then they are asking whether A, B, X, Y will passing through the circle. Okay, so we'll be having a two case. Okay, we have two case. One is, okay, AB, XY. Okay, AB is a point on the circle. X and Y, the point is not on the circle. The condition is AXB is equal to AYB. Yes. In this case, okay, if the 2 points are on the same side of AB, the circle is passing through ABXY. This is first case. If X and Y is not on the same side of AB, if it's in the different side, the circle is not passing through ABXY. Okay, so we have two cases. One is when X and Y are on the same side of AB is passing through the circle. Second case, when X and Y are not on the same side of AB is not passing through the circle. So therefore the answer is it's not necessarily to be passing through the circle. Okay, that is the answer. If X and Y are on the same side of AB, that should be passing through the circle. That's a guarantee we can give. Otherwise, it's not passing through the circle. Here you can just see A, B, X is passing through circle, but Y is not passing through the circle. So question number 3, find X. So X is here. Okay, actually this is A, B, C, D lying on the circle. Okay, A, B, C, D is a quadrilateral lying on the circle. This is called a cyclic quadrilateral. If this is cyclic quadrilateral, we know that sum of two opposite angle is equal to 180 degree or supplementary. Opposite angles of a cyclic quadrilaterals are supplementary. So using the theorem, right, so you can just write sum of two opposite angles. Okay, x plus 100. X plus 100 is equal to 180 degree. Sum of two opposite angles is equal to 180 degree because that is supplementary. Now x is equal to, so 180 minus 100. So 180 minus 100 means x is equal to 80 degree. Okay, x is equal to 80. That's it.
Thank you for watching. Kindly like, subscribe and share. Thank you.